Okay, so the answer to the first question is as follows. Power equals energy divided by time. The next one, the units of power are watts. And now with this question, the first thing we want to do is bug our questions. So the drone can fly for 25 minutes. We're going to underline this and call this our time. The power output of the battery is 65 watts. We're underlining 65 watts and recognizing that that's our power. We're calculating the maximum energy. We're boxing energy because that's what we have to calculate, and we're writing E, that's our symbol for energy. The next thing that we're going to do is list all the values that we know. So we know that the time is 25 minutes. We know that the power is 65 watts, and our energy is unknown, but we know that the units will be in joules. So it's good to pop that on there so that to remind us to add that on at the end once we have our answer. So now we're going to check to see that all of our units are in the correct form. So we want them in the standard units. 25 minutes is not the standard unit of time, so we're going to multiply 25 by 60 to give us the number of seconds in 25 minutes. Remember, if you are converting to a smaller unit, we multiply. So we multiply. The answer is 1,500 seconds. So, and that should get you a mark. The next thing that we're going to do is state the equation that unites all of these values, which is power equals energy divided by time. And now we must substitute. So our power is 65. Our energy we don't know, but our time is 1500. In order to be able to isolate this unknown value, we're going to multiply both sides by 1500 to cancel out that 1500 there. And that should give us an energy of 97,500 joules. Drawing a nice box around it to show the examiner that that's our answer. Okay, so over the page, we are going to do exactly the same thing with this question here. So the battery in the drone can store 97.5 kilojoules of energy. We're going to underline that and recognize that that's our energy. The drone is hovering, the power output of the battery is 65 watts. So we're underlining 65 watts, that's our power. And then we're going to calculate the time. We're boxing time and writing T above there. Next we're going to state the values that we know. And they are as follows. So the energy is 97.5 kilojoules, making sure that we're really aware that that needs to be changed to joules in a moment. Our power is 65 watts, and we don't quite know the time, but we know that the units of time, or the standard units of time, are seconds. So in order to convert 97.5 kilojoules to joules, which is a smaller value, we're going to multiply by 1,000, and that should give us 97,500 joules. The next thing that we're going to do is state the equation that unites all of these values, and that is power equals energy divided by the time. And next we're going to substitute. So our power is 65, the energy is 97,500, and the time is unknown. In order to isolate this time, we need to multiply both sides by T. That should get rid of T on this side. Now we're going to divide both sides by 65 to get rid of 65 on this side. And therefore our time is So our time is 1500 seconds. 1500 seconds. And that's actually, that was the answer to our previous question, so great. Okay, with this next question here, what we were working out was we were trying to calculate the rate of increase at 10 minutes. So we make a little mark at 10 minutes where we reach the curved line, and what we're going to do is calculate the gradient of the line at 10 minutes. So in order to do this, we have to draw a tangent at 10 minutes where the line touches, so that this gradient, so this tangent touches this line here, and then we're going to calculate the gradient of this line. So it's good to draw a little triangle and calculate the rise over the run. So the difference in the rise here is the difference between 960 and 1920. So the change in the y value here is 960. That's our rise value. Our run value is the difference between 8 and 12. So the difference between 8 and 12 is 4. And then of course our equation to find out the gradient of the line is rise divided by the run. Therefore our gradient at 10 minutes is 960, that's the change in the y value, divided by 4, which is the change in the x value, to give us a value of 940 megawatts per minute. Now you could have still got the mark if you wrote anything between 240 and about 270. I recognise, and that's because you may not have been able to identify what this value here was or this value here was, which would have made it tricky to find the difference in the y value here, would have made it tricky to find the rise. Okay, so the next question. To run up the stairs, the student does work against gravity. Turning over. We're doing exactly the same thing as before, so we're going to be bugging our questions. So we're underlining 2,240 joules and recognizing that's our energy. Our time is 2.8 seconds, we're underlining that as T, and then we're calculating the power, so we're writing P above that. We're boxing it because that's what we have to work out. So now we're going to write the values that we know, so 2,240 joules, making sure to add those units on, 2.8 seconds, and our power is unknown, but we're going to add on the units, which is watts. Now we are going to state the equation that unites all of these values, which is power equals energy divided by time. We're going to substitute, so P equals 2240 divided by 2.8, and the answer is 800 watts. So our answer was 800 watts. The answer to the next question is 2,240 joules, because this is the same as the work done. The amount of energy transferred to the gravitational potential energy store is 2,240. The variable that the student kept constant was the vertical height, because they went up the same set of stairs. In this next question, suggest why this conclusion may not be true for a larger group of students. Well, a fast or short time for a lighter student may give the greatest power, and of course the inverse is also true, so a slow or long time for a heavy student may give the least power. This answer to the next question, so we didn't really have much space here. Write down the equation that links efficiency, total power input, and useful power input. So efficiency equals the useful power divided by the total power. And that should be really helpful for our next question. The total power input of the solar cell is 2.4 watts, so we're just underlining that and writing T for total, the efficiency is 0.2, so we're going to write efficiency here. And we're boxing useful, because what we're trying to find is the useful power. So next we're going to write down the values that we do know. So our total power is 2.4 watts, our efficiency is 0.20, our useful is unknown, and our useful power output will also be measured in watts. So we're going to write the equation that unites all of these values, which is efficiency equals useful divided by the total. That should, now we're going to substitute, so 0.20 equals the useful divided by the total, which is 2.4. To isolate this useful, we're going to multiply both sides by 2.4 to cancel out this 2.4 here. And so our answer, 2.4 multiplied by 0.20, gives us 0.48 watts. 0.48 watts. Lovely. Okay. Now, over the page, it would decrease the time because essentially there's less energy in that laptop being transferred, so it wouldn't stay on for as long, so it would decrease the time. With this question we're going to do exactly as we have done before, so we're going to underline our 12 watts and recognise that that's our power. We're calculating the energy, so we're boxing energy and writing E because that's what we have to work out, and our time is 60 seconds. So we can fill in these values here. So our power that we know is 12 watts, our energy is unknown, which is measured in joules, and our time is 60 seconds. We don't have to convert any of these units because they're already in their standard units. Now power equals energy divided by time. Now we're making sure to write the equation that unites all of these values. So we're substituting 12 equals E divided by 60. To isolate the unknown, we're multiplying both sides by 60. So therefore E equals 60 divided by 60 multiplied by 12, which is 720 joules. Our answer was 720 joules. For this next question, all of these are decreases. So a mug with a smaller base means that a smaller surface area is exposed to the heater. So therefore less energy is going to be transferred. A lower power heater again means less energy is going to be transferred. And a plastic mug, now remember plastic is an insulator, so the rate of energy transfer is slower through an insulator than through a metal mug, so less energy is going to be transferred to the liquid per second. So all of them are going to be decreased doing these changes here. Okay, so over the page, actually this was a bit of a foiled question because we weren't provided with enough information to be able to answer this question. We have the time, but we were supposed to calculate the power, but unfortunately we weren't given the energy value in this question, which we really needed to be able to answer this question, so we can't do this. Over the page, final question. Now this last question required us to think about lots of different things and two equations that had to be used together to be able to find the answer. So let's go through them. Let's go through it. So each time the student does one chin up, he lifts his body by 0.5 meters vertically upwards. I'm going to underline 0.4 meters because that's the height. He's going up 0.5 meters. The mass of the student is 65 kilograms. I'm underlining 65 and I'm recognizing that that's our mass. The student is able to do 12 chin-ups in 60 seconds. That's our time. Now calculate the power. We're boxing power, that's what we have to work out, developed by the student. And we've been given our gravitational field strength here, so we are writing G by gravitational field strength. So what I need to think to myself is, okay, I need to calculate power. In order to work out power, I need to know the energy divided by the time. Well, I don't know my power, that's what I have to work out. I do know my time, but I haven't been given any energy values in this question. So in order to be able to answer this question, I need to know my energy. I can do that by working out the gravitational potential energy of this man lifting himself up on this handle. So the first thing I'm going to do is find out my gravitational potential energy. So my EP, I'm not quite sure of that yet, but it's going to be measured in joules. The mass I recognise is 65 kilograms. Our height is 0.40 meters, and our gravitational field strength is 10 newtons per kilogram. Next, I'm going to check if all of these units are in their standard units, and they already are, so we can move on straight away. The equation that unites all of these values is EP equals mass times gravitational field strength times height. I'm going to substitute. So my mass is 65 multiplied by my gravitational field strength multiplied by my height. And so my gravitational potential energy in this question is 260 joules. Now, this is the energy required to lift up, to do one chin-up is 260 joules. However, this man does 12 chin-ups. So I'm going to multiply the energy required to do one chin-up by 12. So 260 multiplied by 12 is 3,120 joules. That's how much energy he's transferring in order to be able to do 12 chin-ups. Okay, that's a really important step. Now that we have our energy value, we can list the values that we know for power. So power is unknown, but it's measured in watts. Our energy, we now know it's 3,120 joules, and our time it takes to do that is 60 seconds. Checking that no units need converting, and they don't, so we're going to write the equation that unites all of these values. Power equals energy divided by the time, and then we're going to substitute, so it's 3,120 divided by 60, therefore our power is 52 watts. So we can circle that our power is 52 watts. And there we go.